Okay, so naming ions. So a monatomic ion consists of a single atom with a positive or negative charge resulting from the loss of one or more valence electrons respectively. So we know cations. Cations are metals, and they lose electrons. They are in group 1A, they form a positive 1 charge, group 2A, positive 2, and group 3A, positive 3. Now anions, they gain electrons and they're negatively charged. We have nonmetals. So group 5A, we have minus 3 charge. Group 6A, minus 2 charge. And group 7A, minus 1 charge. So if I go ahead, we see that cations, their charge is the same as their group number. Now, if you have a periodic table in front of you, looking at your anions, you basically take your group number and you subtract it from 8 because we all want to have 8 electrons in our outermost energy level. So group 5, so we would have 5 minus 8 would give us negative 3. So that's how group 5A nonmetals form a negative 3 charge. Okay, so now my pointer. So naming monatomic ions. So a monatomic cations are identified simply by the element's name. So examples, we have K plus is called the potassium cation. So another example, say we had Mg plus 2. So that would just be the magnesium cation. Now the anions gets a little more trickier. So for monatomic anions, the ending of the element's name is dropped and the ending IDE is added to the root name. This is very important when we start naming and writing formulas. So for example, F minus, instead of the fluorine anion, it's called the fluoride anion. Another example, say we had N minus 3. So it's not going to be the nitrogen anion, it's going to be the nitride anion. So some practice naming cations and anions. So name the ion formed by each of the following elements. Change my color up here. Let's go orange. And so potassium, we know potassium is a metal and it's in group 1. So it's going to be K plus 1. Now lead. So we know the symbol for lead is Pb. And it says 4 electrons lost. So we know, first off, lead is a metal. So since it loses electrons, it's a cation, so it's going to have a positive 4 charge. And then sulfur, we know, is an anion, so it's going to be S. Once again, it's an anion, so it's going to have a negative charge. Since it's in group 6, it's going to have a minus 2 charge. So metals that form more than one ion. On your polyatomic ion sheet that I gave you yesterday, I talked about some elements with charges in parentheses in Roman numerals. So that's what we're going to talk about now. So the charges of the cations of many transition ions must be determined from the number of electrons lost. And all of those charges or oxidation numbers will be in parentheses. So for example, symbols and names of common metal ions with, we're not going to really worry about the stock name too much here. We'll use the highlighter. So we're not going to really worry about this too much. Just want to show you that we have Cu plus 2. And if you would say it, it would be copper 1 ion and the copper 2 ion. Okay, the classical name we won't worry about. We'll actually worry about the stock name a little bit. We won't worry about the classical name. So once again, we look right here, Cu plus 1, so it's copper 1. Cu plus 2, it's copper 2. Same thing, lead plus Pb plus 2, lead 2. And then Pb plus 4 would be lead 4. Now, polyatomic ions are ions composed of one or more atoms. More than one atom. It behaves as a unit and carries a charge, just like a monatomic ion. So note that the number of oxygen atoms and the endings on each name. You should be able to discern a pattern in the naming convention. So if you look here, we have SO3 minus 2, which is sulfite, and we have SO4 minus 2, which is sulfate, right? They both contain sulfur and oxygen, right? But the ATE ending indicates there is a greater number of oxygens. ITE is one less. So the charge is the same on each polyatomic ion in a pair for which there is both an ITE and ATE ion. The ITE ending indicates one less oxygen atom than the ATE ending. However, the ending does not tell you the actual number of oxygen atoms in the ion. For example, the nitrite ion has 2 oxygen atoms. So for instance, nitrite would be NO2 minus 1, and sulfite would be SO3 minus 2. So we see these don't match. But as we go along and we practice more of these, we will remember these. And that concludes the video on naming ions.